Hi, I'm John Turner, Vice President of Innovative Solutions at Gafcon. And it's my pleasure in this presentation to give you a perspective of the journey from BIM to the world of digital twin. First of all, a quick introduction to Gafcon. Gafcon works predominantly with owners, and we work to support their building life cycle in both the physical and the virtual worlds. The physical through conventional program management, project management, construction management services, and the virtual world, which is really my world, which is focused on all the technology elements. But our main passion is to focus on the processes and technologies that enable a complete transformation to that digital building life cycle. So we're going to talk about the world of the digital building life cycle leading to the digital twin. It's just an example of a few of the projects we're involved in for various owners, a wide variety of different market segments, but most of the projects are very large in size, with a focus on what we call serial builders. Those owners who are building substantially the same within their project portfolio, and so they can take advantages of commonality within their projects. First of all, a quick introduction to the Digital Twin Consortium. Both Bentley and Gafcon have been members of the Digital Twin Consortium from day one. It's a relatively new organization, just founded earlier this year. And its aim is to improve interoperability within the world and the markets for digital twin, to accelerate the market and to demonstrate the value of digital twins. Within that, there are a number of activities that we are focusing on at the moment, but we really want the Digital Twin Consortium to become the authority on digital twins, to really be the organization that collects together all the information and all the major players within this market, to define the standards and the architecture and really enable people and organizations to develop faster within this process. To do that, we have to identify any gaps, things which are stopping us from progressing. It's very much an open community. We want to publish as much as possible. We want to work in partnership, but we really do want to drive and propel the world of digital twins. My main focus is in the infrastructure group, the group that is working on both horizontal and vertical projects. And this is a group I have the privilege of co-chairing. We put together a diagram to try and focus our discussion on how we move through the different phases within the life cycle for both vertical and horizontal buildings. But the main focus of all of this is the digital thread. It's how do we support the flow of information through all these phases and into the digital twin in the operational phase in the most efficient manner. And that's really a lot of the focus of this presentation. Many owners are now starting to present what they mean by a digital building lifecycle. Microsoft was one of the first, and Microsoft is a founder member of the Digital Twin Consortium. And they're defining the digital building lifecycle in terms of these 11 phases. But you'll notice that it's very much a data-based process. It's focusing very heavily on BIM, but it's linking BIM to all the dimensions of BIM, focused back not just on the 2D and 3D, but linking back to cost, to schedule, to assets, and even to simulations. And it's also focused on the complete life cycle. So let me start off the presentation with a story. Let's say somebody comes into your office and they place a mango on your desk in front of you. And they say, this mango is infected with salmonella, how can we trace every mango that we currently have within our supply chain, which has come from this batch, and every single person that we've sold this mango or this batch of mangoes to? Now, Walmart can do it, but why can't we within the construction industry? For our large owners with a large building portfolio, if they have a pump that fails, how can they go out into their total infrastructure, all their buildings, and find similar pumps even from the same batch, and so be able to start predicting the instances of failure and to get ahead of the problem? A lot of the problem within our building portfolio is we haven't adopted standards, and so it's very difficult if we have projects from 4 or 5 different GCs, even to define how each of those has referenced that particular pump in terms of names and other attributes, so they can be searched very easily within some form of computerized maintenance management system. So this first question is, why can't we do it? And what are we going to do about it? So I have 3 main questions. What is the current digital thread in the conventional construction process? What should it be to support the digital twin? And how do we get from BIM to twin? Now, for serial builders, there might be other questions. Can we actually end the formality of design and construction and maybe focus on configuring a building and assembling it on site? Start to think of construction as being more of a manufacturing process rather than the conventional construction process. At Gafcon, we sometimes use the analogy of the world is moving from bicycles to cars. But those of us who are used to using a bicycle find it very difficult to visualize a car. If we've never seen a car before, we've never driven one, we don't know what a car does. It's very difficult to start to think in terms of what can a car do to transform our business. And if we think of modern software, we're not just looking at a conventional car, internal combustion engine, we're looking at a Tesla. The functioning parts of that car, the performance of that car can be changed with a software update every 2 weeks. So a large part of our interaction with clients is to try and use this analogy. How do we move from the world of bicycles into the world of cars? Now, if an owner realizes they want to move into the world of cars, they probably have a picture, a vision of what that car should look like. But reality is often very difficult. Sometimes it's not even an instruction manual of how to put that car together. It's just a heap of parts. And quite often our technology providers are only interested in selling part of the solution. They only want to sell a wheel when the client wants to buy a car. The wheel on its own is not very much use. Plus the fact if some other vendor is selling a car, that probably comes with wheels. And so there's less opportunity to start selling the component parts of that car. But the world comes in components at the moment, and that's one of the main focuses of Gafcon in terms of being a digital twin integrator. It's making sense of all these parts from an owner's perspective. Microsoft has defined what they mean by digital twin and how a digital twin can bring advantages in their workflow. And our work at Microsoft has really defined the digital twin into 8 main components. The ability to visualize and 3D spaces, which is very much coming from a BIM-centric approach, to be able to manage the physical assets within that environment, again, can come from BIM. But there has to be a cost performance right the way through. That can start off in the world of project management information systems and can be linked back to BIM through what is commonly known as a 5D link. We also have to start to collate all the documentation, both structured and unstructured. Ideally, we would move all data into some form of structured database. At the moment, it's largely in PDFs or in Office type documents. It's very unstructured. It's very difficult to access that data. As we move more into the world, the operational side of digital twin, we're focused on the Internet of Things, the linking of sensors, and that's a fairly common use of digital twins, the real-time physical performance and control of that physical structure. But there are other aspects of a digital twin which are equally important. The Internet of Activities, where we start to get a realization of how the inhabitants of that building, the staff that we really want to be more productive because of that building, are actually using it. So we want to monitor the dynamics of occupation and learn how people interact with the physical building. We want to also look at our organizational models and see whether we can get insights between the way we're organized as a corporation and the way the model helps us to realize how that organization is impacted by the physical layout of our buildings. To give you an example, if we can start to link the Microsoft Office in terms of booking conference rooms, we know whether conference rooms are being used efficiently. Say we've given a department a 20-person conference room, but that conference room is generally only occupied by 10 people or less. Should we reformat that conference room into 2 so we can make that space more efficient? Everyone is being given sustainability goals at the moment. If we can make sure that our buildings are used more efficiently, maybe we can achieve those sustainability goals without having to rebuild our existing buildings. It's all about understanding how our buildings can be used better. And ultimately, I feel the main use of the digital twin is to collate all the data that's coming from all these different sources, to look at the historical performance, to be able to make predictions and improvements. So we've really defined these 7 main objectives. We want to use a digital twin to actively manage the space, to optimize the physical equipment performance, so we understand the total cost of ownership, so we can use and update documentation necessary to support the building, so we can start to automate and control building environments, maybe predict when conference rooms are going to be used and turn on the heating or cooling just before they're used rather than keep it on constantly. But really it's about optimizing the productivity of our employees, making sure their day-to-day experience is better and constantly improving. And ultimately, if we are going into this process and building a brand new building, how can we do better next time? So what's our current digital thread? Well, buildings are assets, and they contain assets. And these assets can be defined on many different levels, from a portfolio down to individual equipment. Individual equipment could be a table or a chair or a computer, or they could be an operating theater, or any other aspect of how we want to analyze the way our building is going to be used. But when we start to plan a project, we have to convert those assets into a project. Buildings are created through projects, and that project is really orchestrating and coordinating that collection of assets to create that building. But in project management terms, that collection of assets through the project is turned into a schedule and is turned into an estimate and then into a budget. And as we start to deliver that project, we're starting to collect actual costs. Now, all of this is generally done within a project management information system. The problem is there is not a system in the world that currently tracks the schedule and the estimate and the actual costs against those original assets. It's the scope of the project. This makes it very difficult to convert a virtual asset, which is going to be created in the BIM at the start of the design process, into the physical asset, which is necessary to correctly manage and predict the performance of the building when we get into the operational world. But if we introduce BIM, we can change that paradigm. BIM can be the collection of assets which are converted from the virtual into the physical. Gafcon defines a project as really having 7 major life cycles. From these 7 major life cycles, which are generally managed within the project management information system, we define 3 primary. So the project life cycle is where the scope is managed. Most of the tasks of a project manager are managed within this project life cycle. The other 2, what we call primary life cycles, are the procurement life cycles, which is mainly around the contract and the invoicing and the change orders. And then there's a schedule life cycle, which is focused on the organization of the resource and the correct sequencing of that. If you configure a project management information system correctly, you can make sure that any interaction within these life cycles can then be reflected in the other 4 secondary life cycles. So for example, if a project manager decides a change order is required, that can be reflected back into the procurement life cycle. A schedule impact can be reflected in the schedule life cycle, but then the cost of that change order is reflected in the cost life cycle. All the documentation is collected in the documentation life cycle. It's reported in the reporting life cycle. If that change order arose from a risk, then it's all documented in the flow all the way through. So in order to make the project management information system more effective, we really want to create a project management information system that is not only integrating these 7 life cycles, but is also integrating back into the BIM and the BIM workflow. So what should this digital thread be? We've got a fairly simplistic look at this, but if we look at the components of it, we still have to have a cost focus. We're going to have a digital twin focus, but we're also going to integrate the 2 main conventional focuses, which are the BIM-centric focus, predominantly around design, and also the project management information system focus, which is more prevalent within construction. We're going to go through a series of phases which allow us to understand the cost. Scope is converted to estimate, into budget, into contractual commitments, tracked as actual cost, and changed through forecast to completion. We're going to start to understand how the costs are accumulated through our cost breakdown structure and control accounts, how we're going to contract, and so start to get into the commitment cycle. We're going to look at how everything is going to be invoiced, how changes are happening in that. And that really means our scope has to be starting to be decomposed into a work breakdown structure. And we start to look at how the building is designed within this work breakdown structure in order to start aligning our estimates with our ability to control. And if we're looking at serial builders, we're also looking at leveraging a BIM catalog, which is starting to link that data in a preordinated form, not only with the ability to integrate it directly into BIM, but also to link it back to asset data and cost-related data on a collective basis without having to do this individually for every single BIM asset. So this will start to give a focus on all the different pieces that need to be pulled together. But how do we get there? Well, first of all, we have to have a very good understanding of how data is organized within a project. And here we have a simple structure which looks at how data can start to be looked at in different dimensions, in different ways. We can start to break our scope and our budget through our work breakdown structure into the units where we can understand how costs are starting to accumulate. And then we can decompose this, we essentially pivoting that data into an organizational breakdown structure, which understands how we are going to contract. Are we going to go design, bid, build? Are we going to use a series of different contracts? Are we going to do design, build, and so maybe only have 4 or 5 payment cycles? There's a lot of focus on the strategy as to how an owner would contract for a particular project, which then has to be reflected in the organizational breakdown structure and the way the project is contracted. We also have to break it down into work packages. Those work packages are starting to be managed in the schedule, and those work packages can be further decomposed into activities and tasks, so we can start to integrate with lean construction and pool planning. But we also have to make sure that we can track costs. And this is generally where we start to pivot into a cost breakdown structure, potentially through the use of control accounts, which can aggregate different costs and start to align them with work packages. And we'll start to see how this focus on work packages can tie together the world of BIM and project controls. So in very simplistic terms again, if we start to estimate in a different way, we start to look at a focus on construction milestones. Say, break down a wall into 5 component parts. We dig the foundations, we complete the foundations, we build the wall, we finish the wall, and we clean up. Those 5 milestones are assigned a cost within our estimating, and they can be aligned with the BIM elements, which are necessary to go through the design of the foundations and laying out the rebar within those foundations, how we're going to build the wall, how we're going to finish that wall. And so we're starting to get a link from the BIM to the estimating to the approach. We can link that to our scheduling package, how we're going to take those 5 milestones and break them down into a schedule. And so we can start to bring everything together with an alignment of pool planning. We can align the model with the schedule, and eventually we can align the model with the way the invoices are being presented, and potentially in the future more fully align with reality capture, so that we can send a drone or a robot out into the field to see what progress is being made on the building of this wall, and so automatically pay the contractors on the basis of an agreed assessment of progress. So we now start getting into the world of how are we actually going to do this? And we suggest we do it through a focus on what's called advanced work packages. If we can start to design the project, we can start to plan it as an executionable process that encompasses the work from the initial planning all the way through design and into construction. We're not designing with design intent. We're actually designing to manufacture, to assemble that project within the construction environment, within the field. But at the moment, our design processes are very much focused on our legal requirements for an architect to provide design intent. That legally has to be communicated through paper-based 2D drawings. Wouldn't it be better for the design team to focus on how are we actually going to construct or assemble this project on site? How are we going to incorporate DFMA, design for manufacturing and assembly, or pre-construction, or starting to use modules within that design process, and make sure the attributes were available within that design process to enable us to more readily align all the steps within this process with all the different parties necessary to provide a successful project. Now, this is actually possible. And it's possible because if we take the concept of advanced work packages, we can start to decompose these through detailed levels. Those of you who are familiar with pool planning will probably already relate to the level 5. the ability to put together daily work plans when you're working on site. But at the start, we can start at the level 2, we can start to think about how we are designing the project in order to be constructed or manufactured or assembled on site. We're breaking down the work packages into engineering work packages, procurement work packages, construction work packages, and then further breaking those down again into installation work packages. Think back to that slide that I had of linking the work breakdown structure with the organizational breakdown structure, with the schedule, with the cost breakdown structure. And you can see that that concept fits in to our ability to start to decompose these work packages into all of these different levels in order to be able to, excuse me, in order to be able to manage more effectively within the overall digital building lifecycle. So here's an example around that. We can actually extract from the BIM all the components that we need for that particular work package. Let's say, for example, we want to extract maybe all the pipe hangers which are used within a particular area. We want to put all those pipe hangers out to a single manufacturer to be able to provide them in batches of how they're going to be used every day or every week on site, or certainly within the areas, so we don't have to have a central area on site with all the hangers and then distribute them. We can start to look at more a just-in-time type of process. If we have the right attributes in the BIM, this is something that can be done very easily. We can also use tools like Assemble to provide costs against all of these attributes. So if we're attributing the BIM correctly, it's very easy to identify all the components that we want within a particular work package and align those directly with an estimate so that we can start to make sure our procurement life cycle is exactly aligned with the way we're designing and with the way we want to assemble or construct on site. We can also start to align the project management information systems with this. You'll see here that we have a tag in here, 26 CND, which is starting to identify that particular work package within the work breakdown structure and to align it to a particular contract within the organizational breakdown structure. So we're starting to integrate everything so it's very much easier to be able to integrate all these different perspectives on the data through the project management information system and project controls. So here again, we're tying back to a particular vendor through the organizational breakdown structure. We're making sure that we're also tying back the conduit and the cable trays in this case through the work package identification into a particular account code within the cost breakdown structure. So it's very easy to start to align the cost estimates with the actual costs as they start to come in. It's also very easy if everything is in rigorous data form within the project management information system to be able to track exactly what's happening within these individual work packages and to produce very easy reports to see what is on schedule, what is within budget, and how the overall project is progressing. Make sure the project managers are actually able to focus on the good things and the bad things. The good things so they can leverage the good, the bad things so they can fix them before they start to impact the other good things. This can also be aligned very precisely with the schedule. So that as our schedule is broken down through milestones and into the daily activities, we can make sure that not only is that reference number for the work package contained within that, but all the activities and tasks that roll up to it can also be managed within the schedule. So everything can start to be managed in a very tight, very holistic data model. We're not using people to interpret all of this data and to collect all of this data, but we're actually using systems to present it to the project managers so that they can make use of it in managing their projects more effectively. So hopefully you found this presentation of interest. If you'd like to continue this discussion focused around the use of advanced work packages in integrating BIM into the world of digital twin, we're very happy to continue the discussions if you want to take membership of the Digital Twin Consortium. As I say, we have very active discussions within the infrastructure team as to how we're going to bring this to market and so be a benefit to our owners. Thank you.